Hello everyone. I am student of Indian Institute of Information Technology Vadodara, International Campus Diu, and today I am going to give presentation on the SAM 2 course Basic Electrical Engineering. My name is Arpan Gevaria and I am first year student. My course instructor is Dr. Jignesh Patel. I am going to give presentation on hydroelectric power plant. So finally, let's start the presentation. As we all know, hydro means water. So hydroelectric power means electricity generated using water power. Here, potential energy of water becomes kinetic energy when it flows from higher level to lower level. From this kinetic energy, we get mechanical energy in a power plant, which is then turned into electrical energy. Thus, hydroelectric energy is a renewable resource. The damming of streams and rivers has been an integral part of human civilization from its early history. Controversy paralleled this use because impounding and diverting water from upstream users affects those who live, who live downstream and also modifies the local habitats of plants and animals. Dams are built to control floods, improve navigation, provide a drinking water supply, create or enhance recreational opportunities, and provide water from irrigation and other agricultural uses. Let us see the components of the plant and their role in its working. Functioning of a hydroelectric power plant. Hydroelectricity is produced in a hydroelectric power plant. In this plant, the water is released from a higher location. The potential energy present in the water is converted into kinetic energy, which is then used to rotate the blades of a turbine. The turbine is hooked to the generator, which produces electricity. As you can see in image, here are the basic components of a conventional hydropower plant and their role in its working. Let's discuss all the components one by one. The reservoir. Water from a natural water body like a river is stored in the reservoir. This reservoir is built at a higher level than the turbine. The dam. The flow of water stored in the reservoir is obstructed by huge walls of the dam. This prevents the water from flowing and helps us harness the energy present in it. The dam consists of gates present at its bottom, which can be lifted to allow the flow of water through them. Most hydropower plants rely on a dam that holds back water, creating a large reservoir. The penstock. This connects the reservoir with the turbine propeller and runs in a downward inclined manner. When the gate of the dam are lifted, the force of gravity makes the water flow down the penstock and reach the blades of the turbine. As the water flows through the penstock, the potential energy of water stored in the dam is converted into kinetic energy. The turbine. The kinetic energy of the running water turns the blade of turbine. The turbine can be either a Pelton wheel model or a centrifugal type. The turbine has a shaft connected to the generator. The most common type of turbine for hydropower plants is a Francis turbine, which looks like a big disc with curved blades. A turbine can weigh as much as 172 tons and turn at a rate of 90 revolutions per minute according to Foundation for Water and Energy Education. A shaft runs from the turbine to the generator. When the blades of the turbine rotate, the turns a motor which produces electric current in the generator. Giant magnets rotate past copper coils, producing alternating current by moving electrons. Power lines. The power produced in the generator is sent to various power distribution stations through the power lines. The generator. The heart of the hydroelectric power plant is the generator. Most hydropower plants have several of these generators. You can also see images of these generators. Environmental impact and drawbacks. Large hydroelectric dams have a number of negative impacts on the local environment and human society. Dams disrupt river ecosystem and migrations, killing aquatic life that gets caught in turbine blades. Dams also create artificial reservoirs, which floods farmland and forests, displace wildlife and people. Hydroelectric projects are also susceptible to fluctuation in river flows and rainfall. Ghana, which depends on energy from the Volta River Dam, has suffered severe energy shortages in recent years because of lack of rainfall. Large dams and reservoirs in tropical regions are important sources of greenhouse gases. According to Brazil's National Institute for Space Research, each year the world's dams give off over 100 million metric tons of methane. INP scientists are developing ways to produce energy by burning this methane. Let's see some advantages of hydroelectric power production and usage. First, hydroelectricity is a renewable energy source. Hydroelectricity uses the energy of running water without reducing its quantity to produce electricity. Therefore, all hydroelectric developments of small or large size, whether run of the river or of accumulated storage, fit the concept of renewable energy. Second, hydroelectricity contributes to the storage of drinking water. Hydroelectric power plants reservoirs collect rainwater, which can then use for consumption or for irrigation. In storing water, they protect the water tables against depletion and reduce the vulnerability to floods and droughts. Third, hydroelectricity means clean and cheap energy for today and for tomorrow. With an average lifetime of 50 to 100 years, hydroelectric developments are long-term investments that can benefit various generations. They, they can be easily upgraded to incorporate more recent technologies and have very low operating and maintenance costs. Hydropower is non-polluting but does not have environmental impacts. Hydropower does not pollute the water or the rain. However, hydropower facilities can have large environmental impacts by changing the environment and affecting land use, homes, and natural habitats in dam area. Thank you for listening.